In part 2, I'm going to go over the procedures that are used in this method and the logic that's used to call the procedures. If you understand how this method works in the procedures, you should be able to modify it for your particular labware or your instrument setup, your hardware that you have, or you could actually change the method for a different application. The procedures are the building blocks of this method. Okay, now let's talk about procedures, and let's first talk about incubation procedures. Here we define end repair incubation procedure. We do not pass it any variables. Basically, it's a very simple procedure. Basically, it's a T-robot move, takes the plate from a location on the deck, places it in the T-robot, does the thermal cycling, and then brings it back to the deck. All the incubation procedures are similar to this, very straightforward. Okay, now let's look at the add reagent procedure. This procedure is used to transfer reagents from the cold block to our sample plate. For example, when we're adding the end repair master mix, this procedure is called. When you call this procedure, there are quite a few variables that you set when you call it. Change tips between transfer. It's set to a 1 when it's defined, and all the times we call it during this method we change the tips because we're going from one source well to many different destination wells, so we always change tips. Should you mix after you do the transfer? If this is set to a number above 0, it'll mix, and here we have it set to 4, and it will mix 4 times. Here is the mix volume. How much will it aspirate and dispense each time it mixes? When you call this add reagents, do you want it to remove the lid from the cold block before you do the transfer? If the lid is already off the cold block, you don't have to set that to a 1. You can set it to a 0. And when you end this procedure, do you want it to place the lid back on the cold block? And then we got the source well. The source well tells it what well in the cold block is our source. In the Biomek, the top left is well 1, the bottom right is well 24 in our cold block because it's 6 by 4. And here is the volume we're going to transfer. So this procedure is called every time we need to transfer reagents from our cold block to our plate. This procedure is used to add the end repair master mix, the ligase master mix, the blend adapter master mix. It's all the same procedure. We just change the volume we're transferring, change the mixing volume, things like that. But it's all done by this one procedure. Now let's look a little deeper into the procedure. Okay, if you remember, in our 90s or in our cold block, we had two 2 mil tubes. This if step here, okay, those 2 mil tubes were at location 19 and 8 in that cold block. And what this if step does is it swaps the cold block from a 500 microliter cold block to a 2 mil cold block. As this procedure runs, it looks at what is your source tube, and if you're coming from either tube 19 or tube 8, it changes the instrument setup so it knows it's a 2 mil tube. If it's not those tubes, it's going to set the cold block to a 500 microliter tube. Okay, and now this is this part of the procedure where it actually does the transfer. There's 2 transfer options. One if you want to change tips between transfers, and one if you don't. If you're changing tips, it's going to use the one transfer, and if you're not changing tips, it's going to use the other. But it basically transfers from the cold block to our sample plate. And I mentioned earlier that if we use 500 microliter tubes and 2 mil tubes, if you're setting it up where you don't have that hardware and you're going to say use a PCR plate, this is really the only place, this procedure is the only thing you're going to have to change in the method. You're going to have to set it up to use your PCR plate as your source plate. It shouldn't be that difficult. The great thing is once you get this procedure set up to use the PCR or whatever plate you're going to use as your source plate, all the steps, all the add reagents, you call it the same procedure. There's only one place that you really need to modify and get working right so that you can transfer your reagents from your cold block or your 96 well cold block to your sample plate. Okay, now let's look at one more procedure, the ampere procedure. This procedure is called every time we want to do an ampere on the plate and let's look at the variables that we pass it when we call it. The first one is the ampere ratio. By default, like I said, it's 0.6 for the 2K library prep. We got our elution volume. We can change that. Um, there's a couple variables here. Last washover aspiration, and that basically when we wash the beads, we have it set up so we can leave a little volume behind in that. So like if we're doing 3 washes, we may leave 3 microliters behind for each wash except the last wash, and that's what these variables are used for. We have the number of washes. By default it's set to 2. We got the wash volume and the sample volume. Those are all set going into the procedure, so when we call it, we know how much volume is in our 96 well plate. We use that for our sample volume. We know what we want to elute into, what volume, and we set that. Our wash volume and our wash times, I believe most of the time we leave it to 3 washes, and we wash with 100 microliters of ethanol, but you can adjust those if you think they need to be adjusted. Okay, let's look at one more procedure, the define tube to tube. This procedure is only used for making the master mix. It basically transfers from one tube to one tube at a certain deck position, and you can specify that in all the variables that you pass the procedure. We got the destination mix times, how many times you're going to mix after you do the transfer to the new tube or the new location, and the volume here, what the mix volume will be. The destination position, what position on the deck the piece of labware or tube rack is. In our situation, it always stays at P16. This is just used for the cold block making the master mix. And you also specify the destination tube and the source tube and transfer volume. So basically you're just passing it those variables. It's going to do the transfer. If you tell it to mix, it'll mix at the specified volume. The method or the procedure also selects the appropriate tip. If you tell it you're going to make the master mixes on the deck, have the instrument make them, it's going to put up a different instrument setup that has some P1000 tips, P250s, and I believe P50s, and it's going to choose the appropriate tip according to the volume that it has to transfer. One other thing, I mentioned that in the add reagents, if you switch from the cold block to a PCR plate or some other type of plate to keep your master mix reagents, you have to switch that over there in that procedure. Okay, if you switch to a different type of labware for your master mix, this tube to tube procedure will have to be edited also, or you can just make the master mixes by hand and add them to the plate. Once you understand kind of how this method works, hopefully you'll know where to change those things if you need to change those for your application. Okay, now that we've looked at some of the procedures, let's talk a little bit about how the method actually works. We defined all the procedures, so the rest of the method is basically just logic calling the different procedures. And let's start with end repair. So right here is end repair. If add end repair reagents is set to a 1, in other words, yes, add end repair reagents, it's going to remove the lid from the sample plate, add the reagents, and reinstall the lid. If it was set to a 0, it would take the else branch and not do anything. After that, it looks at if the end repair incubation needs to take place. And if it is set to a 1, If you have automated incubation, it will take the plate and put it in the thermocycler and bring it back. If you don't have automated, it's basically going to pop open a window that tells you to take the plate to a thermocycler. And that's kind of how the method progresses from here. It's just a matter of a bunch of if statements. If it's set to a 1, you do it. If it's set to a 0, you don't. But it all, like when you're adding master mixes, it all calls that one procedure, add reagents, and that it uses that same procedure to add all the reagents, whether we're adding the end repair, the ligase. And when you're doing the ampere, it calls that 1 ampere procedure. We can change the elution volume in that ampere procedure. We can change the sample volume going into that ampere procedure, but it all calls the same ampere procedure. So it makes maintaining the method easier. You only have to go change that one step if you're going to tweak it, and it will tweak it in all 4 places, or all the places that it's called in the method. There are advantages to that and disadvantages, but that's the way this method was developed. When the method finishes, the deck layout will be basically exactly the way it was when it started. Your samples will be in the PCR plate at location P7. We will have gone through all the stack of 96 well PCR plates. Every time it does an elution, it goes from one plate, transfers it to a new plate, places the old plate on top of the stack. So this is what the method will look like when it's done. I know I couldn't go over all the details in the method and the development. It would just take too long. I urge you to run it in simulation many times. Get so you understand the method before you run with real hardware. But this should help process samples for the PacBio in either a semi-hands-off manner or a fully hands-off manner if you have an onboard thermocycler. I hope that gives you some idea of how the method works. By running the method in simulation before you use real hardware, trying to understand how it works, doing the modifications you need to do for your particular system, hopefully you can get this up and running and save some time to do library preps. I hope you understand that by using procedures, you can save a lot of time in writing method by making, for example, the add reagent procedure. Once that was developed, it's used multiple times in the method. Instead of serially writing the whole method, rewriting those steps again and again, just make it once, just call it a bunch of times where you can change the variables you set up. It helps in maintaining the method. If you have any questions, feel free to email me. Thank you.